Good afternoon, everyone. Thank you for joining us and welcome back. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, the science and technology channel.
And we didn't point this out, but we are both in Apple Valley again. We're back from the safe house in Utah.
Yes.
And we got a good story for you this afternoon. So
yeah,
here we
this
go.
segment is really cool. Curiosity-driven basement experience led Eric J. Nestler to become one of the world's most influential neuroscientists, reshaping how researchers understand addiction, stress, and resilience. You heard that right. Basement experience as a little kid, curiosity. His discoveries, especially the long lasting molecular switch ΔFosB, revealed how experiences rewrite the brain, sparking global advances in psychiatry. Would you like to know more?
In a newly released Genomic Press interview published December 9th, 2025, so just a couple of days ago, or a day and a half ago, in Brain Medicine, Dr. Eric J. Nestler discusses how a simple fascination with brain chemistry grew into a global effort to understand the biological roots of mental illness. As the Anne and Joel, oh boy, Ehrenkrantz, dean of the Icahn School of Medicine at Mount Sinai, he reflects on nearly 40 years spent investigating how drugs and stress alter human behavior at the molecular level. He should have just come to high school with me.
Yeah, he should have just studied one or two of my brothers.
Yeah. What began with questions about protein signaling in the laboratory of Nobel laureate Paul Greengard eventually expanded into a detailed picture of how life experiences influence the brain's genetic activity. Okay.
Dr. Nestler's scientific path started far from a traditional research setting. In the basement of his family's home in Nassau County, Long Island, guided by his father, a high school biology teacher in the New York City public school system, he carried out experiments that evolved into award-winning science fair projects. These early experiences shaped his approach to inquiry and set the stage for an academic journey through Yale University, where he completed his BA, his PhD, and MD while working in Dr. Greengard's lab. What a success story, yeah?
He's a busy guy.
Man.
Busy guy, working and completing an education like that, right?
Yeah.
That's pretty good. His decision to establish a research group at the Yale Medical School under the name the Laboratory of Molecular Psychiatry proved ahead of its time. The idea of applying molecular biology to psychiatric disorders was discovered or considered bold, yet Dr. Nestler and colleague Dr. Ron Duman believed the field was ready for that leap. The name reflected real scientific ambition. Within a few years, Dr. Nestler became the founding director of the Division of Molecular Psychiatry at Yale, a role made possible when the current director, Dr. George Henninger, voluntarily stepped aside. Yeah, I bet you there was a little help there.
Yeah.
Dr. Nestler often recalls this moment as a defining lesson in generosity and mentorship, one he has carried forward throughout his career.
A central example, it is cool. A central example of Dr. Nestler's influence is his research on the transcription factor ΔFosB. That's the Greek delta symbol, capital S, F-O-S, capital B. This protein accumulates in brain reward pathways during repeated drug exposure and chronic stress, altering gene expression in ways that persist long after the initial experience. I'm going to tell you that from my brother. While most proteins break down quickly, ΔFosB remains active for weeks or months, helping explain why short-term experiences can produce long-lasting behavioral effects. Scientists around the world now view ΔFosB as a key factor in understanding vulnerability to addiction.
The interview highlights the type of deep scientific dialogue featured in Genomic Press's open access journals, which reach researchers across the globe.
Oh, yeah.
The organization's dedication to free access has made it a significant force in advancing the dissemination of medical research. Well, that's cool.
That's propaganda. That was propaganda.
I know it's propaganda, but they're not charging for it. So
yeah, that is cool.
They're just freely giving it. So that's pretty good.
Sharing, yeah. Over the past 4 decades, the focus of Dr. Nestler's work has shifted significantly. Early studies emphasized intracellular signaling pathways. Over time, this evolved into an investigation of transcription factors and their gene targets in specific brain regions. About 20 years ago, his team began studying epigenetic regulation, the chromatin modifications that allow environmental experiences to leave long-term marks on brain function. Of course, that's brilliant. That makes total sense. As new technologies emerged, the research progressed from analyzing entire brain regions to examining individual cell types and eventually to single-cell methods that reveal hidden biological diversity. These advances raise an important question. Could single-cell insights one day enable treatments tailored to specific neuronal populations in individual patients?
Think about it. One of Dr. Nestler's most notable contributions is his focus on resilience rather than disease. His laboratory identified unique molecular, cellular, and circuit level features in animals that continue to function normally despite exposure to drugs or stress, kind of like the human animal. These resilient animals appear to possess biological buffers that protect them from harm. This idea has broad clinical implications, suggesting that understanding natural resilience could lead to entirely new treatment strategies. Okay.
Findings from rodent studies. Now, I resent that.
Rodents?
Yeah, it's like we're downplaying mice. They obviously mean mice, right? Call it what it is. I mean, mice are important.
Maybe they're using some other kind of vermin or creature.
Yeah, it's rather reductive, man. Let's call it mice, okay?
Yeah. Okay.
Findings from rodent studies have been confirmed in postmortem human brain tissue from individuals with addiction and stress-related conditions, reinforcing the translational value of this line of research. Dr. Nestler has authored more than 800 publications, including influential textbooks on the neurobiology of mental illness and molecular neuropharmacology, and his work has been cited over 177,000 times. With an H index of 210, he ranks among the most influential scientists worldwide. Wow, we're giving up some props to this guy.
I have no idea what an H index is, let alone of 210.
Sounds impressive, doesn't it?
It does sound impressive. Yep.
I wish I had an IQ that big. That'd be great.
Yep. If you know what an H index is, let us know in the comments. So, all right,
folks. Thanks for joining us. We hope that you enjoyed this interesting segment.
Take care, everyone. We'll see you tomorrow morning. Have a good night.